Alright, this is section 3.3, rules, page 4. So, other notation, just want to make sure you know all your first and second derivative notation. There's a lot of different ways to write it. So the one we've been using most often, f prime of x. One that I like the most, y prime. So whatever function name you're using, just y prime. How about this one, d dx of the function. So it's the derivative with respect to x of the function f of x. Also capital D sub x, also of the function. So that means the derivative of f of x. And then you've seen this one before too, just dy dx. Those are all first derivatives. Second derivatives, different ways that we can denote second derivatives would be like we did a couple days ago in the notes, f double prime of x, second derivative. We could have y double prime. Okay, so prime for however many derivatives there are. How about this one? Let's use dy dx as our first derivative, and then what we're going to do is show the derivative of that. So there's the first derivative, so this itself is a function, and we're going to show that prime. That indicates the second derivative. In a similar way, how about this one? d dx of dy dx. So there's my derivative function. I'm going to take the derivative of the derivative. That makes it a second derivative of the original function y. And a kind of shorthand way to write this is, I kind of think about this as multiplying going across, which it really isn't, but that's kind of what it looks like. D squared y dx squared. This is the second derivative. Okay, so just some notation you need to get ready for. Alright, let's take a look in the example. They want us to find dy dx, which is just the first derivative, for y equals 21 divided by x cubed. Okay, so this is fraction, obviously, so we could use the quotient rule. And basically what I want to show you is the quotient rule is not really the most efficient thing to do here, especially if either the numerator or the denominator is just a constant. So in this case our numerator is a constant. Let's see the implications of that with the quotient rule. So the quotient rule, of course, we always know for dy dx, you start with the bottom function, x cubed, times the derivative of the top function. Well, the top function is 21. The derivative of a constant is just 0. So the first part of this is x cubed times 0, minus the top function, 21, times the derivative of the bottom. That's going to be 3x squared, all over the bottom function, x cubed squared. Okay, so that's your quotient rule pattern that we have to follow. But here's what's interesting about this. This first piece right here, that's just equal to 0. This whole thing goes to 0. The reason that happens is because we got a 0 derivative from that constant. So actually there's a better way to do this. But let's complete it. If I multiply this through, I get minus 63x squared. In the denominator, you multiply this, so you get x to the 6th. And if I clean that up, I get minus 63 over x to the 4th power, which, I can leave my answer just like that. Alright, so alternatively, usually when I encounter a problem like that, the first thing I would want to do is to rewrite it. I don't want to use the quotient rule here, so we'll rewrite it as 21 times x to the negative 3rd power. The power rule that we learned doesn't care if the power is positive or negative. So we'll use the power rule to get y prime here, which is the same as dy dx, just a different notation. So y prime is equal to, what do? We take the power of the exponent, negative 3, bring that down in front, multiply by whatever coefficient is out in front, 21. The variable stays the same. And the new power, we have to subtract 1. So we have minus 3 minus 1. So y prime is equal to, let's see, this is minus 63 times x to the negative 4th power. Be careful about this. common mistake students make is they will add 1 to the power and put minus 2 here instead of actually subtracting 1, which is negative 4. Alright, let's compare these two answers. They are exactly the same, just written in different form. I could have taken one more step and changed that to a negative exponent. I could take one more step and change this to a positive exponent. Either way, you're going to get the same result. So, point being, quotient rule, I wouldn't use that if you have a constant as part of it because it just makes one piece of it go away. It's really more work than is necessary. A much simpler way to do this is to change to a negative exponent and use the power rule. Alright, a lot of times we get choices, including, in this example, problem number 4. So just at first glance here, a binomial times a binomial. Looking for the derivative of this, immediately you might think product rule. Okay, so I'm going to apply the product rule here. There is another alternative. The other alternative would be just to FOIL these out first. Get a trinomial or a polynomial out of that and then use the power rule. So I'm going to do it both ways. So product rule first and then I'll FOIL it first. Two alternatives. So product rule, here we go. Y prime is equal to, in the product rule, here's my first function, here's my second function. So I'm going to start with first function, y minus x, times the derivative of the second. Derivative of this is 0. Derivative of x squared is just simply 2x. Plus, product rule always has plus. The second factor, 1 plus x squared, times the derivative of the first. So the derivative of this is just simply negative 1. And now we just need to clean it up. I'm going to distribute. So I get 2x minus 2x squared. Over here, if I distribute that negative 1, I get negative 1 minus x squared. And now it's a matter of combining like terms. Let's see, I got minus 2x squared and minus x squared, so minus 3x squared plus 2x and minus 1. There it is using the product rule. That wasn't too bad, actually. If we're going to FOIL it first, that'd prevent having to use the product rule, but I'm FOILing. Let's see, I get y equals, I'm going to go ahead and do first terms. 1 times 1 is 1. Inside terms, negative x. Outside terms, plus x squared. Last terms, minus x cubed. If you want, you don't have to, but if you want here, you could put it in proper order. Proper order would be minus x cubed plus x squared minus x plus 1. And then I'll do y prime using just simply the power rule. This is going to be minus 3x squared. This one, 2x. This one, minus 1. Derivative of 1 is 0, so we don't have to show anything. And hopefully they match. They do. So either method, product rule or FOIL first and then use the power rule.